The objective of this experiment is to determine how much aspirin there is in an aspirin tablet. The weight of the tablet is not entirely because of the amount of aspirin. There are other substances that are not the active ingredient in the tablet. So the amount of aspirin in the tablet is going to be calculated using the percent by mass. To find out the percent by mass of your aspirin tablet, you're going to need the mass of your active ingredient, which is acetyl salicylic acid or aspirin, divided by the total mass of the tablet times 100. In order for you to determine how much acetyl salicylic acid is in the tablet, you will have to determine the absorbance of a series of solutions. Those solutions are known as standard solutions because we know the concentration. We prepare the standard solutions from a stock solution. They are dilutions of the stock solution. So if you know the concentration of the stock solution, you can calculate the concentration of the standard solutions. With the standard solutions, we're going to prepare the samples that we're going to use to measure the absorbance. The absorbance is going to be measured using the spectrophotometer. A light will be passed through the cuvette containing the solution. The solution will be purple. So the light that is passing through, the light can be reflected, transmitted, or absorbed. The amount of light that is absorbed is the one that we're actually recording. That's the experimental data. So your solutions are going to have a purple color, not exactly the same purple color because they have different concentration. The concentration is due to the amount of aspirin that you have in each dilution. The more concentrated solution will have a darker purple color. The amount of light that it's going to be absorbed by your solution is going to depend on the amount of acetyl salicylic acid that is present. Concentration, which is what's telling you like the amount of acetyl salicylic acid that is present, is directly proportional to the absorbance or the amount of light that it's being absorbed by your solute in the solution. So you have the formula for acetyl salicylic acid, but the acetyl salicylic acid will absorb light when it's forming this complex here, down here at the end of the page. It's a complex containing iron, and that complex, it's the one that has a purple color. So your purple solution, it's going to absorb green light or light in the range of 500 to 560 nanometers. And the amount of light that your solution is absorbing, as I already told you, depends on how much acetyl salicylic acid is in your solution. So the higher the concentration, the higher the absorbance. The absorbance value is what you're recording. So for your procedure, you first have to prepare the standard solutions. To prepare your standard solutions, which are the dilutions, you have to prepare a stock solution. So we're starting there. So to prepare your stock solution, you need an Erlenmeyer flask. You're going to weigh your Erlenmeyer flask empty. Make sure that it's clean and dry. So empty Erlenmeyer flask, put on the mass balance, and now record the mass of your empty flask. With the flask in your mass balance, you're going to start adding acetyl salicylic acid, which is aspirin, and I'm going to refer to acetyl salicylic acid from now on as ASA. So you're going to add into your Erlenmeyer flask ASA until the mass of your flask increases by about 0.050. So you don't need to have exactly 0.050, but a number close to that amount. So how you're going to do this, you have your empty flask, and let's say that your empty flask has a mass of 20 grams. So to your empty flask, now you're going to add your acetyl salicylic acid until the mass increases from 20 to something close to 20.05. So you can have 20.052, 20.0498, something close to 0.05. So you're recording the exact mass of the empty flask, and you're recording the mass of your flask with the ASA. You're going to copy all the numbers in the mass balance with all decimal places in your lab notebook. Now to your flask containing the ASA, you're going to add 5 milliliters of sodium hydroxide with a concentration equal to 1 molar. I'm going to use the hot plate to heat your solution. So you're dissolving the ASA in the sodium hydroxide. So make sure that when you're heating up your solution that it does not evaporate. You have only 5 milliliters of sodium hydroxide. It's an aqueous solution, so you have the sodium hydroxide dissolved in water. So you have to be careful that the solution does not evaporate. You can add a little bit of distilled water to make sure that not all the solution evaporates. Now once the solution boils, you can remove it from the hot plate, and now you have the ASA dissolved in the sodium hydroxide, and you can transfer that into the volumetric flasks to prepare the stock solution with a known concentration. So you can transfer your ASA and the sodium hydroxide into a volumetric flask that is a total volume of 25 milliliters. While you're doing this, you can rinse the Erlenmeyer flask with a small amount of water. Remember, the total volume is 25 milliliters, so you don't want to use too much water because you're going to pass the calibration line in your volumetric flask. So you should rinse the Erlenmeyer flask with a small amount of distilled water. And make sure that you transfer everything, that you don't spill anything outside the volumetric flask. Everything should go inside the volumetric flask. Once you transfer everything into your volumetric flask, you're going to complete the volume in your volumetric flask all the way to the calibration line using distilled water. So remember, that calibration line is telling you that that's the total volume of your solution, and that total volume is 25 milliliters. So if you pass that volume, you don't know what the total volume is. So you have to make sure that when you're adding the distilled water, your meniscus aligns with the calibration line in your volumetric flask. So you can add distilled water until you're close to that line, and then you can use a medicine dropper to add water drop by drop until the meniscus is at the line in your volumetric flask. Once you complete the volume, you can cap your volumetric flask and you can mix your solution. That solution that you're preparing in number 4, that's your stock solution of acetyl salicylic acid. You can calculate the concentration, molar concentration of that solution. You know how much acetyl salicylic acid you added, and that's amount in grams. You can convert your grams to moles, and then your total volume is 25 milliliters. So if you have moles of your solute, which is the acetyl salicylic acid, and the total volume, you can calculate molarity. So the concentration of that solution is a known concentration. Now in number 5, what you're doing is preparing the standard solutions, and your standard solutions, they also have a known concentration. We can calculate those concentrations using the equation for dilutions. You have an original solution, which is your stock solution, and from that original solution you're taking different volumes to prepare your standard solutions. So you have your stock solution, the one that you prepare with the acetyl salicylic acid in your volumetric flask with a total volume of 25 milliliters. So from that solution, you're going to transfer some into a beaker, and from your beaker, you're going to use a micropipette to take the volumes that are indicated in your lab manual. So you're using 100 microliters, 200, 300, 400, and 500 microliters. So your first standard is prepared in a volumetric flask that has a total volume of 10 milliliters. So you're taking 100 microliters from your stock solution using a micropipette. You're transferring that volume into your volumetric flask that has a total volume of 10 milliliters. Then for the second standard, you're taking 200 microliters from your stock solution and you're transferring those 200 into your volumetric flask that has a total volume of 10 milliliters. Then you're going to do the third one with 300 microliters, the fourth one with 400 microliters, and then the last one with 500 microliters. So the amount of your stock solution is increasing, which means that the concentration of your standards is going to be increasing. The least concentrated one is the first one, where you're adding only 100 microliters of your stock solution. And then the one with the highest concentration will be the last one, because you're adding 500 microliters of your stock solution. So you have the stock solution, the volumes of your stock solution in your 5 standards. And now you're going to complete the total volume of your volumetric flask. So to your stock solution, you're adding now a solution of iron chloride. That's where the iron that is forming the purple complex with your ASA is coming from. So you're not diluting those standards using distilled water like the stock solution. You're diluting the standards using the iron chloride solution. So again, you're going to complete the total volume to the calibration line of your volumetric flask. But now this volumetric flask, they have a total volume of 10 milliliters. So you're completing the total volume to the line in your volumetric flask using the iron chloride. When you're close to that line, you're going to use a medicine dropper to add the iron chloride solution drop by drop until the meniscus is at the line of your volumetric flask. Cap your volumetric flask, mix your solutions to make sure that they are homogeneous, okay, that everything is mixed through. So the next step, you have your stock solution, you have your standard solutions, and the next step is to determine the absorbance of your standard solutions. So you calibrate the spectrophotometer, and then you have to measure the absorbance of your standard solutions. So you're going to copy in your notebook the absorbance for your 5 standard solutions. Now the next part, it's almost the same as the one that you already did. You're doing your standard solutions to prepare a graph. Now from that graph, you're going to determine the concentration of your solutions that you're preparing using the aspirin tablet. The 5 standards, you know the concentration of those 5 because you're diluting your stock solution with a known concentration to prepare your standard solutions. Now for this part where you're doing the same thing with the aspirin tablet, you don't know how much aspirin is in the aspirin tablet. So the solutions that you're preparing, they have an unknown concentration of acetyl salicylic acid. So we're starting again with an empty Erlenmeyer flask. You're going to determine the mass of your empty Erlenmeyer flask. Now you're going to add an aspirin tablet into the Erlenmeyer flask. So you're copying the mass of the empty flask, and now you're copying the mass of your flask with the aspirin tablet in it. You're going to add to your Erlenmeyer flask 5 milliliters of sodium hydroxide with a concentration of 1 molar. You're going to heat your solution using a hot plate again. You're going to wait until the solution boils, but you're not going to let the solution dry up. So you can add a little bit of distilled water to make sure that the solution does not dry. So a different thing that's happening in this part versus the previous one. In the previous one, you were using acetyl salicylic acid, only that. In your sodium hydroxide, the acetyl salicylic acid will dissolve entirely because that's the only substance that you have. In the aspirin tablet, you have different components. Not all the aspirin is acetyl salicylic acid. So in this case, when you're preparing this, when you're doing this step number 3, you won't be able to see everything dissolving because not all the components in the tablet are going to be soluble in the water. So you will see that your solution does not look clear like the previous one, but that's okay because the acetyl salicylic acid that you have in your tablet, that part will dissolve, which is what you need in your solutions to measure the absorbance. So you're going to prepare number 4, step number 4, in a similar way to that you did number 4 in the previous part. You're going to transfer your dissolved tablet in the sodium hydroxide, that solution from your Ellen measure flask into the volumetric flask. That volumetric flask has a volume of 25 milliliters. So you're going to transfer everything, rinse your Ellen measure flask with a small amount of water, and transfer that also into your volumetric flask. Complete the volume, the total volume, to the line of 25, calibration line in your volumetric flask, using distilled water. That right there is your aspirin stock solution with unknown concentration. Okay, we don't know what's the concentration of that solution, but we're actually going to determine what's the concentration. So moving to number 5, very similar to what you did before, you're preparing dilutions from that stock solution. But instead of preparing 5, we're preparing only 3. Okay? So your stock solution of the aspirin tablet, you're going to transfer a small amount into a beaker. And from your beaker, you're going to pipette using the micropipette the volumes that you have right there, 100 microliters in the first volumetric flask, 200 microliters in the second one, and then 300 microliters in the third one. You're completing the total volume of your standards here of unknown concentration, again using the iron chloride to form the iron complex that's going to give you the purple color in your solutions. Cap the volumetric flask, make sure that everything is mixed, and measure the absorbance of the solutions. So you have absorbance for your 5 standards in the previous part. In those standards, you can calculate the concentration. And now you have absorbance for these 3 standards that we don't know the concentration of acetyl salicylic acid. But we're going to do calculations that are going to allow you to determine what's the concentration of acetyl salicylic acid in that aspirin tablet. Once you're done taking all of your measurements, you're going to put everything in a waste container. You can have a large beaker in your bench, and in that beaker you can transfer all of the solutions that you already measured, the absorbance, any excess of your stock solutions, any excess of the iron chloride solution. Mix everything in the same beaker, clean everything with water, soap water, and distilled water, and put everything back to the original location. The beaker containing all of your waste, you can transfer that waste into the waste container in the fume hood. Make sure that your distilled water bottles are refilled before you finish with everything.